Hello, everybody. Now, I told you I'd be back in a second, but obviously this is the next day. I've got a different change of clothes. So this is going to turn into the Kinetics Review Quiz Review. And we are doing the second half of this now, starting with number 10. So already posted, you will realize that there is the part one. So now we're going to pick it up on part two. So our third scenario in this case is going to be with a girl named Sally, and she's riding a bike, and she's going to have different parts. And so the first part of this, it says that what is Sally's speed at the end of part one? Okay. So in part one, it says Sally accelerates from rest for 8 seconds and travels 32 miles. So just as always, we want to identify what variables we know. So we know that we have the initial velocity, which is equal to 0. The final velocity, this is what we're looking for. And we have a distance of 32 meters, and we have a time of 8 seconds, okay? So we are looking for these variables, and because they we don't have acceleration, right? So since we don't have acceleration, we're going to go to this this equation number one, and although we know that the average velocity is equal to distance divided by time, if it accelerates, we've got the final velocity plus the initial velocity divided by 2. Now, we don't even need to know the average velocity, because if d over t is equal to average velocity and v final plus v initial divided by 2 is equal to average velocity, then we can just set them equal to each other, okay? And this is what we have. So we are looking for that, okay? So our distance is 32 meters. Our time is 8 seconds. This is going to be v final plus 0, because we started at rest, and then we're going to divide by 2. Okay, so we can just ignore this, and if we multiply both sides by 2, then we're going to have it. So 2 times 32 is 64, and 64 divided by 8 is going to be 8, and that's going to be meters per second. So 8 meters per second is going to be the answer to question number 10. Now, we could have already figured out problem number 11, and that is what is Sally's average velocity. And we could just do that from distance divided by time, which is just 32 divided by 8. And 32 divided by 8 is going to be 4. So 4 meters per second is going to equal to our average velocity. Okay, so again, remember that when you see this in the quiz, you're going to kind of get the same setup. You'll see the same questions, but then, or you'll see the same setup, and then you'll see a different question on each of those things. Okay, so you're kind of essentially setting this up just once or twice. Okay, now the third, or question number 12, is what is her velocity at the end of part 2? The end of part 2. So I'm going to erase some of this, and we will look at what variables we know. Okay. So in that part 2, it says she coasts for 28 meters. Okay. So our distance is 28 meters. And we have an acceleration this time of negative 0.5 meters per second squared. And we started out with a speed of 8 meters per second. 8 meters per second. And again, we want to know what the final velocity is. All right, but they didn't give us time. And when they don't give us time, essentially we can go directly to equation number 4, because equation number 4 is the only equation that doesn't have time. So v final squared is equal to v initial squared plus 2ad. All right. So now we have an initial velocity of 8, which is going to get squared, okay, plus 2 times negative 0.5 times 28, okay. 8 squared is 64. 2 times negative a half is negative 1. Negative 1 times 28 is negative 28. That's equal to positive 36. So V final squared is equal to positive 36. We're going to take the square root of both sides, and the square root of 36 is equal to 6. So our answer is 6 meters per second, and that is the answer to question number 12. Okay, again, you guys, when you're doing these problems, you want to identify what variables that you have, figure out what you're looking for, and then figure out which equation you're going to use. Remember, the variable that you're looking for has to be a variable in the equations, and then it's just a matter of figuring out which problems you don't know. Okay. So let's get on to number 13, okay, which is still talking about Sally. And number 13, it says, how far did she travel in part 3? So we go back up to part 3, and it's Sally's. Sally's then speeds up with an acceleration of 0.5 meters per second squared, starting at 6 seconds for 5 seconds. Okay? So again, now, since it's part 3, her initial velocity is 3 meters per second. Our acceleration is 0.5 meters per second squared, and our time is 5 seconds. And we want to know how far did she go, okay? So notice here that we are not given anything about V final, so we can't use equations 1, 2, or 4, and so we can even see here in equation 3, that does not give us V final. We know acceleration, we know the individual or the initial velocity, we know time, and now we can calculate distance. So distance is equal to the initial velocity times time plus 1/2 AT squared. So our initial velocity is 6 meters per second times our time of 5 seconds plus 1/2 of 0.75 meters per second squared times 5 squared. 5 squared. Okay, so 6 times 5 is 30. 5 squared is 25. 5 squared is 25. Divided by 2 is 12.5 times 0.75. That all adds up to be 9.375, okay? So that's going to give us 39.4 meters. And that is equal to our distance. All right, so that is kind of that third scenario. The last scenario is talking about dropping a ball off of a cliff, okay? Very similar to week 1 review 4, those questions. So again, let's take a look at what variables we know. Now remember, when you go to an object that is being dropped or thrown or shot or kicked or anything like that, it is going to be up in the air. So we automatically know that our acceleration is 10 meters per second squared, 10 meters per second squared. Now, is that positive or negative? So if I say up is positive, then down, then this is going to be negative 10 meters per second. Now, although we could say down was positive, when it comes to the quiz, I'm going to say up is positive. So you got to pay attention. You got to pay attention to these, to the signs in this part of the problem. Okay, so oftentimes it's going to help to draw to draw a picture, okay? And what we have here is a 10-meter high cliff, and we're going to take, and this ball is going to be dropped. Okay, so now the question number 14, okay, it says, what is the acceleration of the ball while it's falling? So again, while it's falling, it's going to be 10 meters per second squared. But because up is positive, we need to put -10. So if you see this question on the quiz, and you probably will, there's going to be a choice for 10 meters per second squared, and there's going to be a choice for -10 meters per second squared. Negative is what you want here because we're saying up is positive. Okay, so this is number 14. So when we're going to 15, what is the ball's initial velocity? Well, again, this is an easy one if you just think about it, because it says that the ball is dropped, and that means that the initial velocity is 0 meters per second. So 14 and 15 are super easy. Number 16, what is the velocity of the ball as it hits the ground? Okay, so it's probably good to realize that when this ball hits the ground, we were looking for the velocity as it hits the ground, okay, and which after it hits the ground, it would end up being 0, but that's not the question I'm looking for. As it hits the ground, what's the velocity? If you think of the ground not even being there, okay, it was a higher cliff, and it just passed the 10-meter mark, how fast would it be going? And that's going to essentially be the same question. Okay, so now we know two variables. We know the initial velocity is 0. We know the acceleration is -10. And we also know that the distance is 10. But if we look at this, we have to notice that this is going down. So this, again, should be negative. It should be negative. So -10 would be the answer. So if I asked you for the displacement from the top to the bottom, it would be -10. Okay, so now we want to know the final velocity, okay? So this is what we're looking for, and they don't give us time. Therefore, we're going to use equation number 4. V final squared is equal to V initial squared plus 2GH. Now, the G is just acceleration and the H is just distance. So you could plug it in like this, or you could put AD, doesn't matter, okay? I'm also going to cross out that VI squared because it's 0, okay? So now I can say that 2 times -10 times -10 is positive 100. -10 times positive 100 times 2 is 200. Okay, and that's going to be meters squared per second squared, the final squared. Now, in order to get rid of this, we're going to take the square roots, the square root of both sides. So we're going to get V final is equal to 14.1 meters per second. Okay, that's 14.142 something, something, something. We're rounding that to 1. Okay, but again, this can get tricky because I'm saying up is positive, and if this ball is falling, it's going negative. So remember, -14.1 times -14.1 is still positive 200, okay? And so this is going to be our answer. So don't get fooled by not putting the negative, even though your calculator is telling you what the positive is. Okay, so now the next thing is, how far does it drop in the first 2 seconds? How far does it drop in the first 2 seconds? So let's go back, and we are going to get rid of these values. Now, in this situation, because it's dropped, it's still initial velocity of 0. And because it's going through the air in free fall, it's still -10. So this time, we're looking for distance, and we know the time is 2. and we want to know how far it drops. So we don't know the final velocity, so this is going to end up being equation number 3. Distance is equal to the initial velocity times time plus 1/2 a t squared. And again, the initial velocity is 0, so that goes away. So we're going to have 1/2 times -10 times 2 squared. So 2 squared is 4, divided by 2 is 2, times -10 is equal to -20 meters is going to be our displacement. That makes sense because it is going in the downward direction. So that's why our displacement is negative. Okay. All right. That was problem 17. Problem 18. How long does it take to increase its speed to 20 meters per second? Now, if we're really paying attention here, we know that So we're going to go back to our original stuff here. So this is number 18, and initial velocity is still 0. Acceleration is still -10. This time, we're looking for how long it takes to get to 20 meters per second. 20 meters per second. We're looking for time. They do not give us distance. They do not give us distance. This is the equation that doesn't have distance, so we're going to use equation number 2. So V final is equal to V initial plus AT. So this is going to be 20 meters per second is equal to 0 plus -10 times t, okay? Now, if we think about this, it says, how long does it take its speed to increase to 20? But remember, it's going down, so that's really -20. And now we're going to divide both sides by -10, -10. Negatives cancel out, so we're going to end up with 2.0 seconds is equal to our time. All right, so that is number 18. And now question number 19, which is the last of our review. And the question is saying, how far does it go while it is traveling to speed of 20 meters per second? And this time, okay, 0, 20, -10, and this time we are looking for how far it goes. They do not give us time, so that we're going to end up with using equation number 4. V final squared is equal to V initial squared plus 2GH. Except we are looking for H or D, okay? So again, it doesn't matter. You can put AD or GH, but this is what we're looking for. Okay, our initial velocity is 0, so that VI squared is going to go away. So this is going to be 20 squared is equal to 2 times -10 times our H or our distance, okay? 20 squared is 400 divided by -20H. We're going to divide both sides by -20. 400 divided by -20 is -20. Okay, so that means the distance that it falls is going to be -20. Now, if you guys were paying attention in questions 17, 18, and 19, they kind of were all the same thing because we talked about 2 seconds, we talked about it reaching 20 meters per second, and these were just 3 different ways of having the same information. So in question 17, it says how far does it drop? And question 19, it says how far does it drop? So it ends up being the same thing. The difference was what the starting values that we were given. And then question 18, how long does it take, which was ended up being 2 seconds, which was similar to problem 17 because they told us 7 seconds. I would not count on those things being the same on the quiz. Now remember, the quiz, it will have kind of a similar scenario, but different numbers. So if you do and prepare well for this review, and yes, you have to do the review, even though I'm giving you the answers right here. If you prepare well, you will do well on the quiz. All right, good luck, and we will see you next time.